So I don't know if I have enough time, but maybe if you have a particular question, I can answer that later. But our adaptation lines include working on an hydraulic plan to reduce flooding risks. We are trying to, okay, it's not so easy to green the city. A city like it's already gray, but we are trying to, everybody to have access to green areas, because we have a different social inequity between the north and the south of the city. We are working to improve our emergency response system, and we are proud to say, in 2012, we created the Coordination and Control Center. It's managed by the Civil Defense Department, but it's in the same, a unique center that includes emergency response address from every department. We are improving and trying to increase health system because we have more pressure in the health system. And remember, again, 6 million people, and sometimes people coming from the metropolitan area to the city because maybe the city has a better health system. So we need to think 6 million people again. And trying to relocate vulnerable settlements. Okay. I guess I already went through all of these. I'm sorry, there you have a picture of, this is the, okay. Okay, I cannot point, but there you have a picture of the center I was mentioning, the hydraulic plan, the green roofs. This is mosquito prevention fumigation. That's a health center in a park. Just some examples. Okay. So again, I'm not sure if I will finish my presentation giving the solution of bridging the gap. I don't think so. But I was just mentioned the shocks and stresses we are facing currently. I mentioned them already: rainfall, flooding, infrastructure failure, increasing heat waves. Inequality, we are using a sustainable index now, and it's really different between the north and the south. We have crime and violence and environmental degradation. So trying to improve the health system while improving the emergency response, while working in a support network, including neighbors and community engagement. We are trying to address that as well. And we give emergency grants, but that's in case of big emergencies. So on top, I just try to highlight the actions we are doing that maybe I can say they are short-term shocks response actions. And in the other list, I just try to think about which actions are more related to aiming to prevent, I don't know, we cannot prevent critical situation, but we can make them not so catastrophic. So yesterday they were mentioning the importance of data quality, so trying to improve data development and improve data quality. Increase capacity building through trainings and workshops, working on vulnerable settlements relocation, greening the city again, working on the hydraulic plan. We are working with neighbors, engaging community interactions and now they are volunteering to help and to be ready. We have a program called First Responders in English. It's voluntary neighbors being trained to address an emergency while we wait for the Civil Defense Department to get there. And it's so good to see how much engaged they are, and they are really, really, really willing to help and to be ready for any situation. So again, identifying vulnerable population to increase health, trying to prevent big consequences. So we have an early warning system, and we have the central and control center I mentioned before, but just last year we are receiving the information from the early warning system in the central control, so that will be easier and faster to act in an emergency, and investment in improved infrastructure for sure. So, I mean, my opinion, bridging the gap will, our maybe successful examples I can give of the first steps we are undertaking to bridge that gap. While planning informal settlements urbanization, we are trying to include now sustainable criteria in this kind of urban planning. Social inclusion, again, like neighbors engage, because I don't know if that's the situation in your city, but in our cities, like people are aware they are vulnerable and they live in informal settlements, but they don't want to move because that's their home. So we are working with them to try them to understand why they need to move and for them to feel like the new settlement is home for them again. Trying to increase the support network. And we have a director plan of emergency which identifies 21 threats. 2 of them are directly climate related. So now, as I mentioned before, we have the early warning system and we receive the information directly in the coordination and control center. So maybe that can be an example of we did it separately and now we try to bridge the gap. Our strengths, I mentioned already, we have a legal framework which might be easier in some occasions to work with different departments. So that's why we have an interministerial team. Okay, we were able to gather the team because we have a law that says you need a team. So, but now that we have the team is really willing and understanding the resistance of the way they used to think before and the way they are understanding we need to work and address these kind of issues. So I might mention as a strength as well the transdisciplinary strategy, intersectoral and again interjurisdictional to think long planning. And I will end in a few minutes, I'm sorry. So what I believe the challenges are in planning resilience, is understanding the situation, having a firm political decision to do that. Technical knowledge is like vital, and working together is like the only way to get there. So now we have the opportunity in Buenos Aires to bridge the gap of interjurisdictional interaction and interministerial interaction as well, so as to think of new forms of governance to include social equity in the way we think governance, stimulate dialogue, and they mentioned that on the panel yesterday, learning from experiences. That is like maybe the only way to include a resilience lens when planning the city. So thank you.
Hola, hola. Hola. Okay. Muchas gracias, Inés. Thank you very much. And yeah, we will continue with Sean from San Francisco. So we're going to have all the questions in the end, so please write them down.
Yes, so. All right, which changes it?
Is it working? I'll try the black one. Oh, yeah.
Wait, is that it? Okay. Which one? This one is forward, I guess. Okay, there we go.
All right.
So, I'm from San Francisco. Just a little bit about San Francisco. We're surrounded on 3 sides by water. Our population is 820,000. I know that's going to be hilarious to some people here who come from areas where there's like 10 million people. But we're expecting to grow to about a population of 1 million in the next couple of years. We're completely freaking out about that. So here we are now. Let me just go back. So this is sea level rise. This started happening in the last 5 years, and this is our seawall, which is not at all set up to deal with sea level rise. Here we are now. Just in case you didn't know, we are prone to earthquakes in San Francisco. Our seawall will not last through sea level rise. It definitely is not going to last through an earthquake. So we need to be working on that. When I came to work for the department, it was really just about climate mitigation, right? It's like, we're not going to talk about climate change. We're not going to talk about adaptation because we can tackle this thing. We can do enough energy efficiency and renewable energy and all of that, that it will be fine. And then when we started looking at the seawall, well, now we really have to start talking about adaptation. But we only talked about adaptation internally. We didn't talk about it publicly because the public face was really like, oh, we're going to deal with this. Everybody gets solar panels. And now more and more, we're having to talk about hazard mitigation as well and what is the overlap. And some of that came about, I'm hoping that my next slide is correct because this is a different slideshow than I thought I had submitted. But anyway, so I'm from South Louisiana. An event happened in 2005 that I think got everybody a little bit started thinking about this overlap between hazard mitigation, disaster preparedness, and climate change, and that was Hurricane Katrina. And what happened, so I went back a couple of weeks after Hurricane Katrina. If you've been through a major disaster, you know you get there and the media never can capture it. And it was really like, there's this American film, Jaws, where they're going out to kill this great white shark, and they get out there and the guy sees the great white shark and he turns around to his coworker and he says, we're gonna need a bigger boat. And so when I drove into New Orleans after Katrina, that was my response. We're going to need a bigger boat. And so to me, that is the metaphor. We're going to all have to start working together, whether it's social justice people or public health people or environmental people or disaster prep people. So the next thing that's happened, so that was 2005. Hurricane Sandy in 2009, the conversation really expanded. And so I say, fortunately, in 2009, people really did get that there was this huge overlap between disaster preparedness, emergency preparedness, and global warming and climate change and all of the things that we're going to be dealing with. So we wrote a proposal to the Department of Energy. They had funding available. The purpose of the funding was specifically to advance the photovoltaic market in the United States. So that was their goal. We had a goal of reducing carbon emissions related to energy production, and our disaster preparedness emergency response team had a goal of energy assurance. So we wrote a proposal to the Department of Energy that we would come up with a plan to integrate photovoltaics and storage on crucial buildings in San Francisco, write this into our emergency response plan, come up with a model that other cities could replicate, and they funded it. So we've been working on the idea of microgrids. The project components were to identify the buildings that would be crucial facilities, to look at their crucial energy loads, to come up with a tool that other cities could use where they could load in a bunch of data about their crucial buildings and find out, okay, how much PV will we need, how much storage will we need? And so we have done that. We've identified in all of our neighborhoods potential sites for these microgrids. We've talked to the boards of supervisors. We've talked to community residents. It's a huge collaboration between public health, emergency management, our Public Utilities Commission, the local utility provider, to come up with what are these buildings going to be. Obviously, we don't want to put solar on a building that's going to fail in an earthquake. So there's a lot of things that we need to look at. We're also looking at where are the areas where we have several buildings together, maybe a school, a library, a church, where we can ultimately island those in the event of an emergency. Different than just getting a generator, when we have solar and storage, we can use that right now, right? We can mitigate our carbon emissions right now, but they will also serve in the event of an emergency. So the other thing, I love this idea of shocks and stressors. So we'll be mitigating our carbon emissions the whole time that we've got this installed. But when we're talking about shocks and stressors, we're looking at heat in San Francisco. You know, we're a Mediterranean climate, just like Barcelona, but we're having more and more heat days. We don't have any kind of air conditioning. We do have some vulnerable populations. You know, these areas in red that's downtown, a lot of cement, a lot of impoverished people, a lot of senior citizens. So where will they go in the event of these heat islands? We will be using these microgrids for cooling centers for our vulnerable populations. We're looking at drought. We're going to have a lot more brownouts as a result of energy draw from the grid throughout the state of California. So we do believe that installing our solar, installing the storage is going to help us become more resilient while also reducing carbon emissions, while also dealing with the stressors. And then in the event of an earthquake, we will have electricity for people to come and charge their cell phones, to be able to have food for people. You know, these again are going to be in crucial facilities. So where we are with this project is that we've identified 12 potential microgrids by the end of this fiscal year. So June, we will have 4 of these microgrids designed, and we will be looking for financing. We're already looking for financing. We have something in the States, property assessed clean energy. Looking at that, looking at floating a bond. If the microgrids are going to be on municipal buildings, we could feasibly float a renewable energy bond to finance them. So this is happening, and we're really excited about it. We did a presentation, a webinar about 2 weeks ago with Arup, who did the tool for people to look at, you know, sizing your solar in your building. We had almost 200 attendees for that. So there's a lot of enthusiasm for this project and for this tool, and looking at, okay, what's the roadmap for a municipality to make this work? So it's very exciting. I'm happy to be part of it. Thank you.
Sean, and now we have Angel, who will do his presentation.
Yes, okay, good morning. Well, I'm going to speak about smart planning and smart operation in urban drainage systems. So I'm going to reduce the scope in flooding, in rain problems caused by rain and flooding. So why smart planning and why smart operation? Then these two are ways of facing the problem of flooding, which is caused by climate change. So we have to react to these changing conditions, expectedly worse than those for which the system was designed. So you can go through more expensive solutions like building infrastructures, or trying to adapt with lower cost strategies like smart thinking, smart operation. That's it. It's this one. Which was the? Sorry, no, this one goes back. This one goes forward. Okay. So we try to explain briefly the problems of sewer systems. Then to start with the smart planning, so hazard and risk assessment, smart operation, and finally some conclusions. So which are the more frequent problems in sewer systems? I would say, well, all of them. Odors, flooding for sure, collapses of course, structural collapsing, obstructions, and environmental impacts caused by combined sewer overflows. My speech will focus on flooding and environmental impacts. The causes can be, well, you can see in this table many of them. Some of them are caused by us. We are guilty. We humans are guilty for many of the causes of the problems we have. For very few others, we could say it's the providence. I mean, the orography, the rain, this is not up to us. This is the providence. Well, not exactly, because I would say we are also guilty for rainfall patterns. I mean, we have something to do with that. So I would say the cause of many of all the problems related to flooding and environmental impacts in weather time are the extreme events. And these extreme events and this climate change can act over the city in two ways: increasing rainfall intensity and increasing sea level. In the case of Barcelona, for instance, the sea level is not really a problem because sewers are quite, I would say, half a meter, 1 meter above sea level, so it's not so important. But the rainfall intensity, yes, it is. So these changing conditions will force us to evolve from a traditional management of the sewer systems to an advanced, smart management of sewer systems. And this, it's not a a voluntary choice. I mean, we are forced to that by our citizens, our laws, by the problems themselves, and by the threats. I mean, there are rising threats who will oblige us, will force us to move to this advanced management of the systems. But we are not alone for that. Fortunately, we have some modern tools like GIS and models, telecontrol systems, and so on. So it's not so difficult nowadays to make this step. And if we had mental resistance to that, laws and the social constraints force us to make this step. For instance, in Spain, there is a decree from 2012 which put over the managers of the systems some new obligations like, for instance, monitoring, or the European Directive of Flooding, which put us some obligations concerning hazard mapping, early warning systems. So do we want to make the step or not? We cannot avoid this track. Which are the basic instruments for an advanced management of a thing like, such a thing like a sewer system? Well, there are many of them. The blue one on the top give us knowledge. I mean, territorial information, modeling, telecontrol system, rain gauges, water level gauges. All these kind of systems give you information and knowledge, and with this knowledge you can establish the two main areas, which are smart planning, and the main product is a urban drainage master plan, and smart operation, whose more visible activity are early warning systems. Smart planning and smart operation, these are the two pillars of my speech. Starting with smart planning, the methodology is almost always the same. That is, to assess to make the diagnostic, so to assess the causes, to understand the processes, and then to propose some solutions. So there is always a flood hazard assessment, first of all, with modeling, water heights, water speeds, and so on. So you have to fix what is the threshold for hazard. And then you have vulnerability assessment. That means the capacity of people to resist or to react to this hazard. And then when you combine them, you have risk assessment. So risk assessment is a combination of hazard and vulnerability. For risk assessment, the best way is to make a holistic model of the city. I mean, modeling is and it's my job, so it's the most important part of this history, and the most difficult one, of course, most competent people. And no, but really, being serious, you cannot. Yes, you can learn from experience. Of course, you can. But for extreme events, you have not an extreme event every year. You have to try to anticipate, so to model the causes and the reaction of the system to it. And not only like 10 years ago with sewer modeling, but with coupled models, sewer and street runoff models. Because the reality is that when there is an extreme event, the infrastructures, sewers, are not capable of transporting all the flow. So you have to model both of them and to have and to calibrate these models and to constantly refresh the models. You need an updated model if you want to be reactive to events. I mean, you need to know exactly what is happening. That's it. The product of the static product of the planning process is the Urban Drainage Master Plan, which is the document which puts together your detailed knowledge of the system, your analysis of many scenarios, and the study of adaptive solutions, which, and I very much appreciated your presentations, because you can structure them in structural solutions. I mean, building things, building sewers, building tanks, building concrete, or building sustainable solutions like infiltration devices and so on. And non-structural, that means adaptive solutions. That means land use, regulation, smart operation. If you speak about smart operation, what is clear is that to make this job, you have to have solid procedures, and you cannot invent when there is a crisis. You have to have well-established and studied and validated procedures, which finally it's always the same. You receive data, you process data in a centralized operation system. You have many tools to rely on. Then you have to establish some levels, thresholds for crisis, so emergency levels. And then each level means you have to make actions, operative actions or coordinative actions, inform, act, and etc. And in this field, collaboration is essential, as you told before, because the city is a complex system, much more than a human body, and with different interests. So you have to put all them together and make them work in the right way when there is a crisis. For instance, these real-time control systems, which were a rarity only a few years ago, then now you have them in many cities. These are examples of real-time control systems in our company, and for water and sewer management. And some years ago, this was the exception. Now it's not something so difficult, not so expensive. Almost every city can afford a small a real-time control system. I mean, technology is not expensive. What is expensive is concrete and infrastructures. And then the early warning systems. If you want to operate, one of the actions was the coordinative actions. To coordinate, you need to communicate. You need to inform people. So you have to set up early warning systems, which rely on 3 or 4 brands, like detection, hazard forecast, then risk information or risk computation, calculation, and packaging of some information to communicate and spread this information to managers of the city, to managers of the subsystems, and to citizens affected potentially by a crisis. And of course, there is a 4th area, which is preparedness. And that means forming people to be, training people to be more, to better respond to crisis. And this is the cheapest part of the cycle. And I don't know if it is the most effective, I don't know, but it's one of the cheapest, that is for sure. Well, it's the same idea explained in another sense, but it's always the same idea. Risk information, hazard forecast, communication and preparedness. This comes from the NOAA, the National Oceanic and Atmospheric Agency of the United States. I give you some examples. For instance, this is an early warning system. These are 2 early warning systems. One is near to Barcelona in the Besòs River. It is ruled by the city council, and that in the right is in Santiago de Chile. It's quite far away, but you see, it's always the same idea: a river model, a radar forecast, rain gauges, and water level stream gauges in the river. Well, and in Santiago, snow gauges also, but it's always the same idea. You have to receive information, to process it, to communicate, and in that case, to evacuate the park. Another more tools. This is the Hydromet tool, which belongs to our company, but finally, Hydromet is an early warning system. It's a tool which is implemented in many cities in Spain. You have some plans, and the idea is always the same: is to to predict flood, looking at the radar images. I mean, you receive images every step of time from the radar institution, and then you process it through a model. You have to model, and that's the main innovation of Hydromet. And through the model, you obtain water levels in the network, so you can give alarms, warnings concerning flooding of the network. But this was not enough, because sometimes water doesn't come only through the sewers, but also through the streets. So we developed a project which was called Corfu Project, and which was presented last year in this forum, in this Barcelona Resilience Week. The Corfu Project was presented, and it represents a step forward, which is like the previous slide, but you add to it plus rainfall forecast, hydrology processes, but you have added the 2D modeling. I mean, the modeling of the flow in the streets. And that is very important because it's more realistic. And so, yes, we made some risk maps offline. And then with that maps, you can give more precise warnings to people, because sometimes water, many of the damages caused by water are caused by runoff water. So that's the idea, and this was the first time that when a flood resilience index, FRI, was calculated in Barcelona, in fact in the Raval district, which is not so far from here, and it was calculated taking into account many parameters. The last step is, what was lacking in the Corfu project was the online modeling, the online 2D-dimensional modeling. And this, we are achieving it now by the means of a European project called PEARL, and in the city of Marbella, in the central district of Marbella city, which is in the south of Spain. And this time, yes, we'll be able to make online prediction with a 1D and 2D model, a coupled model, and we can reproduce in real time the behavior of the sewers and the streets, taking the images from the radar and from the rain gauges. So it's quite, it's the top in early warning systems. There are also other kinds of early warning systems concerning, for instance, environmental impact of sewer overflows in the beaches. COWAMA, we call it. It's a tool to assess pollution in waters, in bathing waters, and then to through a model of the receiving waters, and then we can inform people, public information, or managers, which is quite a more technical or private information. And that's all. So, as I said, nowadays there are many factors that push us to progress from a traditional to an advanced smart management of our sewer systems. To make this, two pillars are fundamental, which are the holistic planning and the smart real-time operation. And this smart real-time operation means warning systems and hydraulic regulation. You can act over flows, you can manage flows, you can divert flows, you can store them. An early warning system relies on a tool of components, but the essential two are the detection and forecasting and the communication, timely, precisely, and understandable information given to the managers of the sewers, of the city, of the streets, and to the citizens affected by this flood. So this approach is increasingly adopted at national and at international level, and I can see some examples from other cities, and they are exactly the same. And well, our company has some experience in that because we have implemented some early warning systems in Spanish and other cities. And that's all. Thank you.
Okay, yeah. So actually we're going to move this way to the panel. We have just a couple minutes left for the panel. I will ask a couple of questions, and then if we still have time, I'll open for some questions from the audience. So I'll ask you to be brief with the answers. But I really wanted to know what you were mentioning, Angel, that technology is not expensive. So we've got a lot of information we can use for early warning systems. That's okay. But translating that into infrastructure to actually adapt, which is something that we also need, that is actually a big gap. What ways there are to kind of bridge that gap?
Yes, we also need people for the sharks. Yes, and fish sharks. Yes, that's true. I mean, we really need infrastructures. It's a balance. It's a balance between both of them. You cannot face all these problems only with adaptive solutions like training people and early warning systems. These are important pieces of the puzzle, but it's true that you need also some infrastructures. And that's the balance. So I see no gap. They are complementary measures, and you have to live with both of them, of both categories. I don't know which is the right balance. It probably depends on the size of your pocket, of your money, I mean. It's easier to make great infrastructures if you have a great amount of money. But as I said, it's quite cheap to start with early warning systems and adaptive measures to start with.
About financing, because I don't know, I was kind of shocked when you said, oh, technology is cheap, because I think all of us sit here and go, no, it's not. But maybe, I don't know where. Yeah, so again, financing is an issue. When we got the funding from the Department of Energy to look at how we're going to do microgrids in San Francisco, the three challenges were, okay, looking at the barriers for financing, technological barriers, and policy barriers to carrying out that kind of infrastructure. So I think that we have some good answers, but we don't have big pockets.
Yes, it's true. And sometimes even if you were to have some part of the big pockets, not always technology is available, at least in the area or in the region. So that's a big discussion that has been on climate talks about transfer of technology. You don't seem to agree to that?
I really agree with that. I mean, there is more technology in a smartphone nowadays than the technology you have in a yes. I think yes, technology is available for almost everybody. You find the last models of smartphones in every country, everywhere. The technology behind us on early warning systems is not so complicated. Apart from the radar, the rest is models which are everywhere, and communications, simple communications, I would say.
All right. Something else that I really wanted to highlight here is that Sean, you in one of your slides where you have the 3 spheres there, you actually managed to clearly explain and differentiate what would be a hazard mitigation, which is not only climate related. So you face earthquakes. Inés, you mentioned also crime and other like human-based kind of catastrophes. So this is the mitigation, the hazard mitigation part, whereas climate adaptation is directly related to what climate change can do. So what is, in your respective cases, how are your cities, or how is in the case of Suez, integrating that can be human-made or can be an earthquake or another non-climate related hazard mitigation integrated with the climate adaptation bit?
Well, one of the things that we're doing, there's obvious connection with all of these things, but the biggest connection in San Francisco is this idea of community engagement. So adaptation, hazard mitigation, climate mitigation, there's a huge community engagement piece for that, whether it's the community is the business community, the policymaking community, or residents in a neighborhood. And one of the things that they have found, certainly in the U.S., is neighborhoods that are the most resilient, and this is about crime, this is about education, unemployment. Neighborhoods that are the most resilient are the neighborhoods where people know each other. And so for us, it's really important at all of these different levels, from emergency management, from climate adaptation, to build resilient neighborhoods just by having the neighbors know each other, just by developing mechanisms. And this is where technology comes in, where neighbors can communicate with each other, and that will help no matter what the stress is, no matter what the shock is. So yeah, that's huge.
Yeah, like in my specific situation, as I mentioned, coordinating the interministerial team, like the big challenge is to make people not to think only about their particular task. So maybe the Civil Defense Department was so proud of buying more generators to be ready to energy shortage during the summer, and the mitigation team was like, no, please don't do that. So sitting them on the same table, just starting to bridge that gap of thinking together how to address, for instance, public lighting, efficiency in public lighting versus violence, because people, like, they feel insecure if they have less light in parks, for instance. So that's why I mentioned we are just overlapping the first steps, but sitting everyone in the same table and trying to understand each other, that's like the big challenge we are facing right now.
I don't know if we have time for one question from the audience. We can't seem to be at the hour. Okay, maybe we can get one question. Yeah. We could take two questions and ask and answer them together, and we have to close the looking
Just
at me.
a very small question for Angel. How about modeling in 3D?
Yes. Modeling in 3D.
I have a very quick question. I was quite interested in the case of Buenos Aires about how you're dealing with the relocated communities. I think that's quite interesting in the case when you were mentioning at the very beginning to plan cities that are also involved in informal settlements. How are you dealing with that?
Yes? Do you hear me? Yes. I will try to answer to the first, modeling in 3D. Well, yes, it is possible. 2D models can also perform, some 2D models can also perform 3D modeling. But I don't see quite the point. I mean, when you speak about surface runoff in the city, heights are not so important, so 3D processes are not so relevant. When we speak about the quality of receiving waters, then yes, you have to proceed with 3D models to better reproduce the movement of the pollution in the receiving body.
Thank you. So we have different kind of challenges regarding that particular point you're raising. In the first place, interjurisdictional interaction, because it's not only local department to build houses and to relocate people, but then when that's done, we have a social habitat, we call it social habitat and inclusion department. They are doing an amazing work, let me say, engaging the community and just talking to them and knowing like what's the fears they are facing, or why don't they want to move. Or it was funny because we have like a pilot project including solar collectors in an informal settlement that they didn't even have a gas connection, and we just installed the panels and the solar collectors, and the following day we went to like see how it was working. They just put their clothes to dry to the sun, like on top of the panel. So we were like, oh my God, we need to start over. We are getting there.
Okay, unfortunately we don't have more time for questions, but I want to thank the panelists for your great presentations. Have been very interesting and inspiring. And thank you everybody else for attending.